In this video, we're going to look at how to graph a parabola that smiles, one that opens up, because A right here is a positive number. We're going to look at how to graph this using 5 points. I'm going to begin by just writing down the values of A, B, and C. A is 1. Don't forget there's an invisible 1 here. B is 4. And C is equal to -4. So right away, we know a point on this parabola. We know from the last lesson that the y-intercept of a parabola is C. And since C is -4, I know that the y-intercept is located at -4. So we're going to go to the y-axis. We're going to go down 1, 2, 3, 4 places. And right there is the first point. We're going to graph 5 altogether. All right, the next thing we're going to do is we're going to draw the axis of symmetry. Remember, that's the line that divides the parabola in half, where each half is a mirror image of the other side. And in the last lesson, you learned that x is equal to the opposite of b over 2a. So since b is 4, the opposite of b is -4. And that would be 2 times a. So that would be -4 over 2. So x equals -2. That is the equation for the axis of symmetry. I'm going to draw that axis of symmetry. So I'm going to go to x equals -2. Remember, from first semester, only one variable means only one axis is crossed. And since the variable is x, it crosses just the x-axis. So it's going to be a, oops, broke my pencil. So it's going to be a vertical line crossing the x-axis at 2. All right, the next thing we're going to do is we're going to reflect this point over the line of symmetry. Remember, the line of symmetry cuts the parabola in half with mirror images on both sides. So from the axis of symmetry, this y-intercept is 2 units to the right. What does that tell you? It tells you that there has to be a point at the same level, same height, 2 units to the left. 1, 2. So there's a point right here. All right. So we've got 2 points so far. We haven't done much math for those points. We haven't had to so far. But now we're going to input x equals -2, which is going to be on this line of symmetry, to find the vertex. Because remember, the line of symmetry goes through the vertex. So it's going to be y is equal to -2 squared plus 4 times -2 minus 4. So what you have done is you have input -2 into the x values here. Now we're just going to follow PEMDAS. -2 times -2 is +4 plus -8 minus 4. So y is 4 minus 4 is 0, so you have -8. So the vertex is located at the point x is -2, y is -8. So here's the line of symmetry. It's going to go through the vertex. We're going to go down 8 units. 1, 2, 3, 4, 5, 6, 7, 8. All right, that's the vertex. Now all we have to do is find two other points. We're only going to really use math to find one of them, and then the other one we're going to use symmetry for it. I like to pick x values for this next point that are very, very, very easy to use. And I'm going to choose an input of x equals 1. So I want to find out what the output's going to be. So it's going to be y is equal to 1 squared plus 4 times 1 minus 4. That means that y is equal to 1 plus 4 minus 4. That means that 1 plus 4 is 5, minus 4 is 1. So when the input is 1, the output is 1. 1, comma, 1. Plot that, 1, 1, and then we're going to reflect this point across the line of symmetry. This point is 1, 2, 3 units to the right. So the symmetry point, the reflection point, is going to be 1, 2, 3 units to the left. And then we're just going to draw as good of a curve as we can. My artwork is not very good. And that's it. So the next video will show you how to graph a parabola when a is negative.